So we need to differentiate polynomials. So the rule for differentiating polynomials, okay, a polynomial is y equals ax to the power of n plus bx to the power of n minus 1 plus cx to the power of n minus 2, right down to you have a number with x to the 0. Okay, remember from your rules of indices, x to the 0 equals 1. So that number is just, that term is just the number d. Anyway, so the rule dy by dx, okay, you bring n down in front. So it becomes n ax to the power of n minus 1. You take 1 away from the indice. Actually, let me do this easier. Okay, so that's what a polynomial is. But let's do an example. Okay, the rules. If you've got y equals x to the power of n, dy by dx is you bring n down and it's x to the power of n minus 1. And if you have y equals ax to the power of n, dy by dx, you times the n by the a at the front. So you bring the indice down and take 1 away from it. So those are the rules. So because this is technically a 0 here, any number term disappears. Okay, because 0d to the x, even though that's minus 1, just becomes 0. Okay, but so this will be easier as we go through examples just to show you. Okay, so example 1. Okay, find dy by dx if y equals 10x squared plus 3x1 plus 4x4, sorry, just plus 4. Okay, we just write it like that. Okay, so I'm going to do one thing here, but I'm not going to do it in the rest of them. So that x is really a 1, and that really has x to the 0. Okay, so using our rules of differentiation, okay, the 2 comes down in front, 2, 10x, 2 take away 1. Okay, I'm not going to do this every time, but I'll do it here. So you bring the 1 down, and then it's times by 3x to the 1 take away 0, and then you bring the 0 down, and that's 4x, 0 take away 1. So putting this all together is 20x to the 1 plus 3x to the 0 plus 0 times anything, and then we don't write it like that, we just write 20x. Remember, x to the 0 is 1, so 20x plus 3. So what I do in this, what I would do normally, and what I'm going to do from now on, is just say dy by dx, bring the 2 times 10 is 20, take away 1 just becomes x, and then any x term just becomes the number. Okay, so all this working out that I've shown, you don't need to do that. Okay, so let's do sorry. Okay, so my solution. First derivative, so 4 times 6 is 24, and x to the power 4 becomes x3, minus 3 times 3 is 9, and then that becomes squared. That becomes 2x. The x term just becomes the number in front of it. Remember, there's just a 1, and the 7 disappears. Okay. Sorry, give me 2 seconds. The computer has. Okay, example 3. Okay, we need to be able to do, if you have okay, so we need to use rules of indices to write this on the top line before we differentiate. Okay, so just be careful with your notation. So this, I haven't differentiated here, it's still just y. So 6x cubed plus 3x minus 4, so I can differentiate those. But that 2 over x is 2x to the minus 1, and that 3 over x squared is 3x to the minus 2. So now I differentiate. Okay, so 6 times 3 is 18x squared plus 3. The number 4 just disappears. So now we're working on this one. So bring the minus down. Minus times by 2 is minus 2. Take away 1 from the indice. Minus 1 is minus 2. Then here we're doing minus 2 times by minus 3, which is plus 6. Then you take away 1 from the indice, and it's minus 3. And then just to rewrite it, it's nicer to rewrite it with positive powers only. So remember that x squared can go to the bottom, and that x cubed can go to the bottom. So fractions, when we have fractions, it makes things a bit harder. So let's do example 4, but you just treat fractions the same way. So example 4, find dy by dx if y equals half x to the 4 minus 5x to the 3 over 2 plus 4x minus 2. Okay, so we have dy by dx is, oh, sorry, dy by dx. Okay, so you bring the 4 down, so we 4 times by a half x to the 3. Then we bring the 3 over 2 down. So that's 5x. 3 over 2 take away 1 is a half. And then that just becomes 4. So 4 times a half is 2. Then this, you just keep it as a top-heavy fraction. So it's 15 over 2 x to the half plus 4. Okay, so example. Find dy by dx if y equals 4/5 x to the half minus a half x to the 1/3 plus 2/3. So use your calculator for this. So dy by dx equals 4/5 times by a half is 4 over 10, which is 2/5. That becomes half take away 1 is minus a half. Then we've got minus a half times by a third is 1/6, and that's minus 2/3. And the number just disappears. So if you want, you can rewrite this as 2 over 5x to the half minus 1 over 6x to the 2/3. Both lines are correct answers. Okay, and then So let's do another one. What was that I was on? So this is example 6. Okay, so this is harder than is in your assignment. So y equals 1 over 3 root x plus 4 over x cubed minus 6 over cube root x. Okay, so we need to rewrite this before we start. So y equals, so just be careful, that's a big 3, it's not cube root. So, well, we'll write x, square root x is x to the power of a half. So we'll keep it like this. And cube root x is x to the power of a third. Those are my rules of indices. So y equals 1/3 x to the minus a half plus 4 x to the minus 3 minus 6 x to the minus 1/3. So at the minute I have just rewritten it. I haven't differentiated. So now I'm going to differentiate. So a third times by minus a half is minus 1/6. Take away 1 and it's minus 3 over 2. So minus 3 times by 4 is minus 12. Take away 1 is minus 4. And then minus 6 times by minus a third is plus 2. And then take away 1 is minus 4 over 3. So that's the correct answer, or dy by dx. If you don't like, you can write minus 1 over 6x to the 3 over 2 minus 12 over x to the 4 plus 2 over x to the 4 over 3. Okay, so that is trickier than is in your assignment. So let's do one last example, and then there's 2 exercises for you to do. So example 7. Find dy by dx if y equals 2 over x cubed plus 4 over 3x to the 2/3 minus 7x. So in my solution, I rewrite it first. So it's 2x to the minus 3. That 4 over 3 stays. It's just the x you bring up. And then minus 7x. So now we're ready to differentiate. So 2 times minus 3 is minus 6. Take away 1 and we've got minus 4. So 4 over 3 times, it'll be minus, and that'll be 8 over 9. Take away 1 and you've got minus 5 over 3. And then the x term just becomes the number. Okay, so the rules always stay the same, just fractions or whatever negative numbers doesn't make a difference. So minus 8 over 9 x to the 5 over 3 minus 7. So both lines are correct. Okay. So there's now 2 exercises, exercise 1 and exercise 2 with the work solutions in there. So you can try them all, or you can just pick and choose.